Hey guys, so this is just a video to help you study for the test on your own and check your answers. So looking at this guy right here, the vertex would be this point. Let me put my pen on. This point right here is the vertex. So that the coordinates of that point would be, if you start here, here's the origin. I'm going to go right 2 and down 1, 2, 3, 4, 5. So the vertex would be 2, -5. All right, the slope, I'm going to look at going from this point to another point where it exactly crosses, and actually it looks like it goes through here, here, here. So this would be up 1 over 1, up 1 over 1, up 1 over 1. So the slope here is 1. All right, this one goes up 1 over 1, up 1 over 1. And then I've got the dashed line. Okay, so I know it's not equals, and then I also have this shading here, right? So I know it's an inequality. And then the symbol, though, if it's shaded above the absolute value, that would be a greater than. All right, and then with no equal to, just strictly greater than because I have the dashed lines. And then looking at this one, so here's the vertex, right? The bottom of the V. So that would be, let's see, 0, 1, 2, 3, 4. So 0, 4 is my vertex. And then if I look at the slope, I can see it's a little flatter, so it's less than 1. So let's see, I go down 1 and over 2, right? Down 1, over 2. So that would be 1, right? Down 1. So that is going to be 1 half. Oops, 1 half. That's terrible writing. My cat wants to go outside. Hang on, I'll have to let her out in a second here. Let me check my writing. So the slope is 1 half. All right. And it's going to be an inequality because it's shaded, right? And the symbol is it's shaded below, so that will be less than. And then this is a solid line, so it will be less than or equal to. All right, awesome. And one last thing, as long as we're looking at this, when we're talking about the slope here, so it's upside down, right? So you could think of it also as a negative because it got reflected if it's upside down. So in front of my absolute value is going to be a negative 1 half. Okay, so that's how you do those. All right, so the thing that is we're going to add over here is like putting actually the function here, writing it out what it would be. So maybe I'll do that up here just so you can see how this goes. So if I'm doing the function here, I'm going to put, I'll do this in green. So I'm going to do, I've got, nice, okay, f of x, and then my it's equals, and I'm going to put, my slope is 1, so I'll just say my absolute value of x, and then it was shifted to the right 2, so that's going to be x minus 2, and then it went down 1. All right, so I went from here, I went to the right 2 and down 1, so that will be a minus 1 here. All right. And then here, if I'm writing the function, I'm going to say f of x. The parent function is absolute value because it's that v. My slope is 1, so I don't have to worry about something in front. And then my vertex, it went to the right 2, so that would be minus 2. And then it went down 1, 2, 3, 4, 5. and then so that would be minus 5. And then you check these with by putting it into Desmos. And then here I'm going to write my function, so I'll say f of x equals, now I do have this slope here, I've got the reflection to make it upside down, so I'm going to put minus, and then it's a compression, so put minus a half, and then I'll put my absolute value of x, and it's not shifted to the left or right, it is just up 1, 2, 3, 4, it's just up 4. So I will just leave it as x, and then I'll put a plus 4. Okay, so you can do these next 3 on your own, hopefully. Here I'm looking at the transformations. So I've got, it is flipped upside down, so that is a reflection. Over the x-axis. And then it is also a little bit steeper, right? If I'm going from here, I would go down 2 and over 1, down 2 and over 1. So that is going to be, that's going to be a stretch. By a factor of 2. All right, because my slope is 2 over 1, right? Down 2 over 1. All right, so that's a factor of 2. That's a steeper slope. And then it is shifted to the right. I forgot to count while I was 1, 2, 3, 4. So to the right, 4. Shift right, 4, and then it is down to get to this vertex, right? If you look at where the vertex is, here's my vertex, so I went to the right 4, and then I went down 1. So that's just a shift down 1. Okay, and those are called transformations. All right, so now it says draw the graph. So what you can do is just put this into Desmos, all right, and then you just put it on there to check it out. If you want to try it first by going through the transformations, I could say, okay, it's going to be flipped upside down. It's going to be stretched by 3. That's my slope is 3. And it's going to be to the right 2 and down 1. Okay, if I look at this, this is going to make it go to the right 2, and this is going to make it go down 1. So I'll do my vertex first. So I'm going to go to the right 2 and down 1. So there's my vertex. And then now what I'm going to do is look at the slope. So the slope is my part right here, the -3. So I know it is going down. It's upside down and it's steep. It's got a slope of 3. So I'm going to count 1, 2, 3 over 1. All right. And then 1, 2, 3 over 1. All right. And then now this is less than or equal to. Okay. If you look at this part right here, it's less than or equal to. So it's going to be a solid line. And it's going to be less than, so I'm going to shade below. And then what you're going to do is check out your answers on Desmos. All right, just type that into Desmos and see if it matches this graph. So, in looking at this, are there any solutions to this graph? If I look at this, are there any x-intercepts And this would be, no, there are no x-intercepts. I guess I don't want to talk about it like that. And we talked about this in class. All right, and then now again, this one you're just going to put into Desmos. Here's your parent function. So it looks like there's, oops. All right, so when x is 0, y is 0. When x is 1, y is 1. X is 2, y is 2. When x is negative 1, y is positive 1. When x is negative 2, y is positive 2, right? The absolute value makes everything positive.